Here at the planetarium, we study the Earth. And what is the Earth made of? Rocks. Think of the coolest rock that you have ever found. What did it look like? Where was it from? Was it from nearby? Far away? What made it cool to you? Want to know the coolest rock that I know of? It's actually here at the Clark Planetarium, and it is from a completely different planet. It's not even from Earth. That's crazy! I'm Mercedes, and today I'm going to show you the Martian Meteorite. When you first hear Martian Meteorite, what do you think of? You know that a meteorite is from outer space. It's a rock that was in outer space and it landed on Earth. But why is this one Martian? What makes it a Martian meteorite? Did we send somebody, an astronaut, to Mars and have them bring it back? Not yet. We're working on that. And if we did send somebody out and have them bring a rock back, we actually wouldn't call that a meteorite because it's now not a space rock that was floating around and then crash landed on Earth. It's something that we brought back. So what is a Martian meteorite? Early in the history of our solar system, collisions between planetary bodies were a lot more frequent. Those collisions could cause debris and rocks from the planet's surface to be flung into outer space. Now, in order for those rocks to make it into outer space, they would have to escape at escape velocity. That is the speed that is required for an object to escape the planet's gravitational pull, such as Mars, right? So Mars was bombarded a lot in its history by asteroids, just like our moon and the Earth too. And those rocks got cast into outer space at escape velocity. Now, those rocks would, wander around space for a bit at whatever trajectory they were thrown at, and sometimes would get pulled into the gravitational pull of another planetary object, such as Earth. So this rock was knocked loose from Mars by a meteorite impact on Mars, and then it became a meteorite when it reached the Earth. It's meta. It's a meta-meteorite. Now, if you're thinking like a scientist, you might ask yourself, how does Mercedes know that this is a Martian meteorite? How do I know that this rock is actually from Mars? This meteorite has tiny spaces inside it that are filled with air. These are called vesicles. Scientists can analyze the composition of the gases trapped in those vesicles. The composition of the gas did not match what we had here on Earth, but it did match the atmospheric composition of Mars. So let's think like scientists again. How do we know what the Martian atmosphere is made of? Well, we have a myriad of robots on Mars to thank for this information. The Viking probes that landed on Mars in the 1970s were the first to send back information on the composition of Mars' surface and rocks. We have satellites orbiting Mars that send back pictures and chemical analysis. We have rovers like Curiosity, which can study the composition of Martian rocks. And even some telescopes can study the chemical composition of what stars and planets are made out of. This meteorite has the same chemical composition of rocks that we find on Mars. This guy isn't a very big sample. He's actually part of a bigger meteorite called the NWA 1068. Scientists like to classify each meteorite with a name and a number. The name NWA actually stands for Northwest Africa, which is where this little guy was found. There are slightly over 100 meteorites that have been confirmed as from Mars. That's pretty rare. In fact, out of all of the planets, we only have meteorites from Mars. Why do you think that is? I'll give you a hint, but I won't tell you the answer just yet. Here's a lunar meteorite. This is a rock that came from our moon. Your hint? Think about the size of the moon and the size of Mars and how that might play a role in meteorites coming from these planetary bodies. Thank you for watching. Keep exploring, keep asking questions, and keep looking up.